NASA's New Horizons spacecraft has dramatically reshaped humanity's understanding of the outer reaches of our solar system, providing a historic first-ever close-up exploration of the Pluto system. Launched in January 2006, New Horizons was designed to traverse vast distances of space to deliver unprecedented scientific insights about the distant, icy worlds residing in the Kuiper Belt, a vast region beyond Neptune filled with relics from the early solar system. The mission achieved its crowning achievement in July 2015 when it performed its closest approach to Pluto, revealing a world far more complex and dynamic than anyone had imagined. Prior to New Horizons, Pluto was merely a distant point of light to astronomers, observed only through telescopes and limited spacecraft imaging. It was often categorized as a cold, frozen dwarf planet with little to no geological activity. But New Horizons upended these assumptions entirely. As it passed by Pluto at over 30,000 miles per hour, the spacecraft captured astonishingly detailed images of a surface covered in vast nitrogen ice plains, towering ice mountains, and evidence of recent geological activity, including tectonics and glacial flows. The data revealed a surprisingly young and active surface, implying that Pluto retains internal heat and possesses a geologically dynamic history despite its small size and distance from the Sun. The flyby not only transformed our view of Pluto, but also provided vital information about its moons, particularly Charon, Pluto's largest companion. Charon, nearly half the size of Pluto itself, revealed a fractured, canyon-ridden surface that hinted at a complex geological past. Smaller moons such as Nix, Hydra, Kerberos, and Styx were also imaged, showing irregular shapes, varying surface compositions, and orbital dynamics that challenged existing models of how such satellite systems evolve. Observations of Pluto's tenuous atmosphere, composed primarily of nitrogen with traces of methane and carbon monoxide, revealed intriguing seasonal changes, suggesting that even these remote worlds can host dynamic atmospheric processes. After its groundbreaking encounter with Pluto, New Horizons continued its voyage deeper into the Kuiper Belt, carrying humanity's curiosity and ambition further than ever before. On January 1, 2019, the spacecraft performed a flyby of Arrokoth, a smaller Kuiper Belt object, KBO, located more than 4 billion miles from Earth. Arrokoth, previously nicknamed Ultima Thule, is a pristine relic of the solar system's formation, a cold, distant body that has remained relatively unchanged for over 4 billion years. Unlike Pluto, which is geologically active, Arrokoth represents a time capsule of the early solar system, preserving the original materials and structures from which planets and other larger bodies formed. Its discovery and subsequent flyby offered scientists a rare opportunity to study the primordial building blocks of planets and to understand how objects in the Kuiper Belt coalesced in the early epochs of the solar system. New Horizons observations revealed that Arrokoth is a contact binary, consisting of two lobes that gently merged, providing direct evidence supporting theories of how small KBOs formed through low-speed accretion rather than violent collisions. This discovery has profound implications for our understanding of planetary formation across the cosmos, suggesting that the processes that shaped small bodies in our solar system may be universal. The Kuiper Belt itself, where both Pluto and Arrokoth reside, is a vast, icy frontier beyond the orbit of Neptune. It contains thousands of small, frozen bodies composed of rock and volatile ices like methane, ammonia, and water. These remnants of the early solar system offer a window into its primordial conditions, acting as both time capsules and laboratories for understanding planetary evolution. Many KBOs are irregularly shaped and possess surfaces that are relatively unchanged over billions of years, making them excellent subjects for studying the conditions and processes present during the solar system's infancy. Observations from New Horizons help refine our models of solar system dynamics, from the migration of giant planets to the processes that govern the evolution of minor bodies. The spacecraft's findings underscore the importance of direct exploration in complementing ground-based telescopic studies, as the latter often cannot resolve surface features or detect subtle atmospheric changes in such distant worlds. In addition to its core scientific mission, New Horizons also plays a vital role in contributing to the broader field of heliophysics, the study of the sun's influence across the solar system. As the spacecraft moves outward, it traverses regions where the sun's influence wanes and interstellar space begins, entering areas largely unexplored by humanity. According to a study released by the U.S. National Academies titled The Next Decade of Discovery in Solar and Space Physics, Exploring and Safeguarding Humanity's Home in Space, continued observations from New Horizons, along with those from the Voyager spacecraft, are crucial for gaining first-hand knowledge of the outer heliosphere and the transition zone to interstellar space. This region, where the solar wind slows and interacts with the interstellar medium, represents a dynamic boundary of the solar system, where charged particles, magnetic fields, and cosmic rays interact in complex ways. Data collected by New Horizons provide insights into how our solar system interacts with the surrounding galaxy, how cosmic radiation propagates, and how planetary systems may shield or expose themselves to energetic particles. Alan Stern, principal investigator of New Horizons at the Southwest Research Institute in Boulder, Colorado, emphasizes the importance of the mission's extended exploration beyond Pluto. According to Stern, the spacecraft's continued journey provides unique scientific opportunities that cannot be replicated by any other current mission. The National Academy's validation of New Horizons' significance highlights the mission's unparalleled contributions to both planetary science and heliophysics. Beyond its immediate discoveries, New Horizons embodies the spirit of human exploration and the quest to push the boundaries of our knowledge. Its observations extend the reach of human experience far beyond Earth, offering a tangible connection to distant, frozen worlds that were once nothing more than faint points of light in the night sky. The spacecraft's ability to operate effectively so far from the sun, where solar power is insufficient, demonstrates the remarkable engineering achievements required for deep space missions. Powered by a radioisotope thermoelectric generator, New Horizons converts the heat released by decaying plutonium into electricity, enabling instruments to function in the frigid environment of the outer solar system. The mission's instrumentation suite, including high-resolution cameras, spectrometers, and particle detectors, allows scientists to study surface geology, composition, temperature, and atmospheric properties. Over the years, the team has continually optimized operations, balancing data transmission back to Earth across billions of kilometers with the need for ongoing observations, ensuring that New Horizons remains scientifically productive long after its initial objectives were completed. Looking ahead, New Horizons continues to provide a bridge between the inner solar system, where human activity predominates, and the vast, uncharted outer reaches. Its flybys of Pluto and Arrokoth have already reshaped planetary science, offering concrete evidence that distant worlds are more dynamic and diverse than previously imagined. The spacecraft's observations contribute not only to our understanding of individual objects, but also to a broader comprehension of solar system formation, evolution, and the interactions between planetary bodies and the interstellar environment. By combining planetary exploration with heliospheric measurements, New Horizons exemplifies the interdisciplinary approach necessary for a complete understanding of our cosmic neighborhood. Moreover, New Horizons' journey inspires future missions that will continue to explore the Kuiper Belt and beyond. Scientists and engineers are considering follow-up missions to additional KBOs, as well as advanced spacecraft capable of traveling further into interstellar space. Each new mission builds on the foundation laid by New Horizons, pushing the limits of technology and human ingenuity while expanding our scientific horizons. Public engagement with the mission, driven by spectacular images and intriguing discoveries, underscores the broader societal value of deep space exploration. By revealing distant worlds and their hidden complexities, New Horizons fosters a sense of wonder, encouraging educational initiatives, and inspiring the next generation of scientists, engineers, and explorers. In essence, New Horizons represents a milestone in the history of space exploration. Its successful Pluto flyby in 2015 and subsequent Arrokoth encounter in 2019 mark the first steps into the final frontier of the solar system, the vast Kuiper Belt region. The spacecraft's continued voyage beyond these destinations offers the potential for new, unexpected discoveries, as humanity's reach extends into interstellar space. With each transmission of data back to Earth, New Horizons not only expands scientific knowledge, but also embodies the enduring human desire to explore the unknown. As it sails onward, the mission continues to fulfill its promise, delivering insights that illuminate the distant, icy realms of our solar system and enrich our understanding of the universe we inhabit. For New Horizons, as its very name suggests, the gathering of exploration science is indeed always on the horizon, propelling humanity toward ever greater comprehension of our cosmic origins and our place within the vast expanse of space.